Today's topic. It's Introduction to Prompt Engineering. This is an AWS Discovery Day. So Discovery Days are these free sort of short sessions that AWS has built, and they allow our AWS training partners like ExitCertified / Ascendient Learning. That's the company I work for. I've worked for a long time for a company called ExitCertified, and now, Ascendient Learning brings together these three companies, WebAge Solutions, ExitCertified, and Accelebrate, together in one big company. Um, ExitCertified has long been the company that does a lot of vendor authorized training. So about 11 years ago, we started teaching AWS courses, and we do a lot of cloud and cloud related training. So we call this our cloud centrics diagram. In the middle, of course, AWS is our biggest partner, but we're actually partnered with all of the public cloud providers. And then we have all kinds of things that we do around cloud. And these days, there's nothing more exciting in cloud than generative AI. And so that's the real topic today. I'll come back and talk a little bit about some of our courses and how they map to certification at the end of the session. So let me just pop this other slide deck up. And this is the official slides that AWS provides us. Let me get this out of the way. I got all kinds of things in my way. All right. Oops. Huh. So here it is, Introduction to Prompt Engineering. Uh, we're going to talk just a very little bit about foundation models, the concept of generative AI and large language models. The goal here today in an hour is not to teach you how generative AI works and how to really get in there and fine tune models or any of that. Really, we're going to concentrate on, if somebody has built and trained a model, which there's lots of good models out there, um, how can we use it most effectively? And that comes from what a concept called prompt engineering. And we're going to see a few different techniques. These are not all of the techniques. But before we get too far into prompt engineering, let's start with a quick overview of the idea of foundation models, and in particular, large language models. If you've been paying attention over the past, I don't know, 15 years, you probably know that machine learning has gotten very ubiquitous. We use it in all kinds of industries. Now, traditional machine learning, you usually start with a whole bunch of data, right? Because what machine learning is doing is trying to mimic what humans do in looking for pattern recognition and things like that. And so you're typically taking a bunch of data that very often is already labeled, right? So you might look at, I don't know, financial transactions over the last 10 years, and they've either been marked as, was this fraudulent, yes or no? And then you try and train this model to go and look for patterns so that it can predict when a new transaction comes in, is this fraudulent? Should we flag it, yes or no, right? And so that's how traditional machine learning works. You have a bunch of data. Maybe you've gone and labeled it. So we have some what we call supervised learning, where we've labeled the data like that. We also have some unsupervised models where you're saying, look at all of these transactions and try and maybe classify it, like market segmentation for marketing purposes, right? So what's similar amongst all the people who buy this kind of a product, right? And so that's normally what's going on with those. So you've got a very specific set of data, and you use that to train a very specific model to do kind of one thing and do one thing well. Well, over the last few years, we've seen a new kind of a very particular kind of machine learning come along called generative AI. And with those, what we're building is something called a foundation model. And instead of training it on very specific data, it's trained on just a mass amount of data. We actually call it pre-training, right? We say, go and here's all the data on the internet, go and train this thing. Now, the pre-training is usually done by, large companies with large resources, right? Because the compute it takes to do this is very, very expensive, right? So a foundation model uses a sort of what we call a deep neural network that emulates how the human brain works to do complex tasks. But the nice thing is, once you've pre-trained this foundation model, it can be adapted to do all kinds of things, not just, solve this one problem. And so, you could build chatbots, you can answer questions, you could maybe generate images, it could take a whole bunch of text and summarize it for you, right? And so this is the big idea, is that it's kind of jack of all trades, maybe master of none, right? And these foundation models typically fall into a couple of different categories. There's ones that really just primarily works with text, right? And other ones where you're saying, here's some text, like a description, go and draw me, a high quality image based on that, right? So there's different foundation models that do different things. The ones that are really text to text, we usually call those large language models or LLMs. And that's become a big, term these days. Now, there are lots of large language models out there. When I say Gen AI to you, you probably think something like ChatGPT. ChatGPT is very popular. ChatGPT is a very specific kind of end user tool, right? You get this, you sign up for an account, and you get this thing where you can kind of chat back and forth. And I can ask it questions like, what are the top 10 most popular, foundation models? So I'm going to actually ask it this, and we'll get a list of some of the other ones. So ChatGPT under the covers is using, here we go. There it is. It's using GPT-4 or 4.5, depending, which one you're using, from a company called OpenAI, right? And so notable use, it powers ChatGPT, but it also powers some other things like Microsoft Copilot is based on OpenAI. From a company called Anthropic, we have Claude 3. That's a very popular language model, safety focused, strong on comprehension. So they each have their sort of like what they do well and what they don't do well. Google has Gemini. It's now, really tightly integrated with Google. When you do a Google search, if you start it in a form of a question, it'll actually probably the first thing you see is a Gemini answer. From Meta or Facebook, we have Llama 3. This is a very popular one. It's excellent for fine tuning, widely adopted in the open source software community. Um, Mistral does a lot of LLM apps, Cohere, uh, X, which is Elon Musk's X AI company, has Grok. It goes on and on and on, right? So there's lots of different foundation models. So chances of you having to build your own from scratch, where you'd have to have a lot of compute and a lot of really generative AI engineers who really know what they're doing, you're not doing that. you know. So these large language models, what do they actually do? Like how do they take all this corpus of documents on the internet? What are they doing when they're doing that pre-training? Right? Well, essentially what they're doing is they're taking this input data and they're breaking it up into what they call tokens. A token is, usually maybe one word. It could be part of a word. So here it takes this sentence, a puppy is to dog as a kitten is to cat. And it's going to try and learn something from the context of that. And what it does, it takes all these words and it puts them, these tokens, and puts them into an embedding, like as a vector. Now, here we can only show two dimensions in a PowerPoint, but you can imagine, like here you see cat is pretty close to feline and it's pretty close to kitten. Um, but kitten is close to young, probably closer to young than it is to old, just like puppy is closer to young than it is to old. And puppy is much closer to dog than it is to cat, right? So you get that kind of context from it. And again, this isn't great because we're trying to show in 2D, but they use multi dimensions to build these embeddings. And it all kind of ends up with a probability type thing when you're asking it to generate new, sentences, this large language model. So let me show you sort of an example of this. Um, so here, here I've got a tokenizer. So if I say, what was it? Puppy is to dog as kitten is to cat, period. And so it would take this, and how would it break it up into tokens? It says, okay, puppy is to dog as kitten is to cat, and then the period. And now, so it's typically like one word is one token, but you got words that are sort of like I don't know, wondrous or something like that, and it says, well, that's wonder, and then us, so it might be two tokens, depending what's going on. And so when when you're doing generating text, what it's really doing is picking like what's the most likely next word when it's generating a sentence. So here I've got a sentence which you may have heard before, never going to give you up, never going to let you, what's the next word? Well, it says 78.85% is probably down, you know. So that's, of course, Rick Astley song, right? But even if I take that example we just did, where I say, what was it? Puppy is to dog as kitten is to, give it a second to catch up. Hmm. Seems like I might have to reload this page here. See what's going on. Throw that back in. Okay. So puppy is to dog as kitten is to, interesting. They're not really sure. Like 15% dog, 11% cat, puppy, pet, wolf, kitten, you know. So it's sort of guessing what's the word. Now, this is written with a really old GPT-2 that only has 124 million parameters. So it's not a very powerful LLM, but they just used it to, because it's cheap to build this kind of a visualization thing. So this is not, super smart, but you will see that we're in the right area here. And it doesn't always take the top prediction. Like you can set what we call the temperature, and there's top P and top K, and so there's a few little knobs we can tune to get it to be more creative or less creative. And so this is really the underpinnings of how generative AI works. It's all kind of doing a little bit of probability stuff at some point. Now, what do we do with it? Well, we could do things like, here's a whole bunch of documents. I want you to summarize them, right? So my LLM knows all about English language. You give it a whole bunch of English documents, and it'll go in, you know, um, uh, summarize that for you. So there's all kinds of use cases for LLMs. We do it a lot in customer experience, chatbots, call analytics. Yeah, go look at my calls and see where I went wrong, agent assist, all that kind of thing in customer service. Um, yeah. Uh, Boost employee productivity, right? So you probably are using something like this. A lot of people are. It turns out whether or not their company is allowing them to or not. And we'll talk a little bit about that. Conversational assist, code generation. If you're a developer, you can tell it, go write me a Python program that does this and this and this. It'll generate a bunch of code. Now, is the code going to be 100% exactly what you want? Not necessarily, but it at least gets the boilerplate done for you nicely, and you can just make little tweaks if you need to. It can automatically generate reports, right? So this is where we're seeing, a lot of companies that use Microsoft 365, they go and pay the extra and get Copilot in Excel, in PowerPoint, and all those places. So those are all using, again, the GPT-4 under the covers. Okay? Um, Creativity and content creation, right? Go write me a blog post, things like that. Accelerate process optimization. So it can process documents, look for fraud detection, do some optimization things. Now, the problem is, I mentioned earlier, jack of all trades, master of none, right? That pre-training only builds, a very general model. And how can we get it better at what we need it to do? Well, there's kind of there's really three different options here. After the pre-training, you could go and do fine tuning. Well, like we said, I could do the pre-training myself if I've got a whole bunch of computers with a lot of GPUs, go spend millions of dollars and build this huge data center, with a bunch of GPUs, um, or rent them from a cloud vendor and do it, So you could build your own, but more likely what you'll do is take one of those existing foundational models, and I could say, well, I've got this whole corpus of documents that have to do with, things that I work in. Maybe I'm in legal or I'm in healthcare or whatever. And I say, okay, here's a whole bunch of very specific articles from medical journals, that are very pertinent to what my company does. So I'm going to go and say, take everything but now let's do extra fine tuning. And what it's really doing is, like all those vectors that were created, it's changing the weights of them based on this new information that we know is more pertinent to us. And so fine tuning can really take a model and make it more specific for, say, particular tasks, or probably more specific to a domain, right? So you give it a bunch more knowledge on, healthcare, or whatever your business domain is. The problem with fine tuning is, just like the original pre-training, it takes a lot of compute. So it takes a lot of time and a lot of money, to do that fine tuning. And so that is a good way to really tweak a model and make it more specific for you. But the easiest and fastest way to harness one of these existing pre-trained foundation models is to just do a better job of asking it what you're looking for. And that's really what prompt engineering is. And so prompt engineering is the fastest way to harness the power of these large models. And so that's what we're going to look at here today. The key concepts of prompt engineering. And, at a very high level, you typically have these four elements when you write a prompt. And again, it doesn't matter if you're using ChatGPT or Gemini. Those are examples of like end user tools, right? Um, Under the covers, those are using a specific foundation model. Now, I'm going to use in my examples, I'm going to use Amazon Bedrock. So Amazon Bedrock is Amazon's um, nicely managed service that gives us access to all kinds of underlying foundation models. So if I go and look at what models have I been granted access to, I could go and request a whole bunch of them. But if I look through this list, I just grabbed this from one of our labs. We got a couple from Amazon themselves. These tend to be the cheapest ones we can use in AWS. The old ones were Titan. Now they've got these new ones called Nova. So I got access to Nova Micro and Nova Canvas. So Nova Micro is a LLM, so it's for text to text. Nova Canvas is more for generating images, right? But I think I have some other ones in here. We've got Claude 3 Sonnet, which is wildly popular. Okay, I'll use that. Okay, so I'm going to come in here to my playground, and I'm going to do the chat/text one. Now, chat is if I'm going to send it a prompt, get a response, and then, have a conversation with it. Say, oh, I want to change this. I want to change that. Here, I'm just going to do just a single prompt here to begin with. And I have to select my model. So I'm going to go through and pick Anthropic Claude 3 Sonnet. Okay. And then there's some of those like randomness and diversity things that I said that we can tweak. Again, that's a little outside of the scope of this 1 hour session on prompt engineering. But essentially down here it says, hey, write a prompt. Okay, so we're going to come back to that. Let me catch up with the slides again. Okay, so these are our four main areas. So we've got some instructions. What do you want the thing to do? What is the task? And so you give it some sort of description and instructions. The context is more of like external information that would be good to guide the model. Input data. This is the actual input for which you want a response. The question, whatever. Output indicator is something about the output type or the format. The more specific you can be, the better, right? So here's an example where we told it, I want to write a summary of a service review using just 2 sentences. right? And it's an online store, shipping, and here's a review of Amazon Student Prime. And so somebody wrote this really long review, and so we want basically a two-sentence summary of this service. And so it spits out this. This is well, the first sentence is pretty long, the second one's pretty short. And so if we look at it, what are the elements here? Well, that first line is actually doing double duty. It's the instruction, right? A summary of the service review and a bit of an indication of what the output should be. Two sentences. Right? Then we've got the context, right? This is what we're doing. And then here's the actual input data is the review itself. And so, if we like this, we think it's pretty good. Well, then I could, that's fine if we're doing it here in, actually, let's do this. I'm gonna, where'd it go? Let me come back and actually grab that text, see what Claude Sonnet does with that. Okay, so I'm going to tell it to write this review, summary, colon, and it comes up, okay, provides an excellent value for college students, offering free shipping, access to streaming. I don't know if I can blow this up a little bit so you can see it better. Free shipping and convenience it offers makes a worthwhile investment for busy students juggling studies and other responsibilities. And so it's a different sentence than the one we got, but it's, something like that. To be honest, even if I did the same prompt to the same LLM tomorrow, I might get a different, because there are those probabilities in there. And we're not always taking like necessarily the exact top answer. Tells me a little bit about the number of tokens input and output and how long it took and some of that kind of information. Now, this is a little bit like ChatGPT. I get, if I've got a chat, if I turn on the chat part, I can go back and forth with it. Of course, if you're more of a developer, you're not looking for an end user tool like this. You want to embed this stuff in an application, right? So everything we're doing here in Bedrock, we don't have to use this, what they call the chat/text playground. We can do it through an API. And so, programmatically, I have an application that says, go look in this database of all these reviews and go and make, two-sentence summaries for all of them and put that into somewhere, right? And so that's where Bedrock really comes in is when you're trying to build real applications under the covers, not just an end user tool like ChatGPT or Gemini. All right. And here I can copy that and go do something with it, or I can clear it out and do another thing later. All right. Let's catch up with the slides again. Okay, so we saw context. So here's some best practices. So first thing, like I said, be clear and concise. You don't want any ambiguity because it'll just make its best guess if you don't tell it what you want, right? So you want natural flowing language, coherent sentence structure, because that's what it expects, because that's what it knows how to read well, right? You definitely want to include any kind of context that you can, any additional information, the type of business, what does the company do, anything you can give it extra, it can help it, figure out how to make the answer specific to you. Okay. Next up, use directives. So this is if you want a particular output format, like do you want it to be a summary or do you want it to be a poem? Like you tell it exactly what you want, and that's what you're going to get. And I guess not just directives, but tell it exactly what the output should look like. You can mention exactly what the format you want it to be is. Right? Typically, you want to start your prompt with a question, like what is the thing that you're trying to do, right? Who, what, where, when, why, how, those kinds of things really help. Providing example responses. So we're going to talk about, one shot, few shot kind of ideas. We'll see what we talk about there. But if you provide examples, then it can pick up the output format from that, right? And now I would usually tell it that those are examples so that it doesn't confuse that it's part of the question or whatever. You say, here's some examples of what I would like it to look like. When we get to really complex tasks, you can break it up in several ways. Like if it's If it's a really complex task, you could just ask it to do one step and then ask it to do another step and then put them together. Or there is a way we're going to see called chain of thoughts where we tell it, hey, do this complex thing, but think step by step, and it'll kind of show me the intermediate answers that it got along the way and how did it get to its final, right? And experiment, be creative, right? Try different prompts to optimize the model's responses. You can try a bunch of different prompts till you start to get the right kind of answer, and then embed that in your example. So let's take a look at a few examples, and maybe in the chat, where did the chat go? Here we go. Maybe in the chat, tell me which one's better. Right? So which of these prompts follows my best practices? Prompt one or prompt two? Now they give you a little hint here. Be clear and concise. Which of these is more concise? Larry says two is more concise. Right? Yeah. Yeah, look at two. It's just what's the sum of these numbers? That's all you need. The sum total of the subsequent sequence, like it's a little bit wordier than we need. Right? So try and be clear and concise. That was one of the big ideas. What about this one? Which is following the best practices? Summarize this article, and then we have, the whole text of it. Provide a summary of this article to be used in a blog post. Well, again, number two, everyone's telling me, yes. Number two is telling us a little bit of the context. It's going to be used in a blog post. So it's read a lot of blog posts. It knows what those look like. So it can do a little bit better job of providing the kind of output we want. Now, much better would be what kind of a blog post for which kind of website, like you can get a lot more. Who's the audience? Is it a technical audience? Is it for children? You can be very specific about that kind of thing. Use directives. Here, what is the capital of New York? Provide the answer in a full sentence. What is the capital of New York? Right? If you don't provide that second thing where we tell them what we're expecting, well, then who knows what we're going to get? We could just get Albany, you know? Here, we actually want it in the answer in a full sentence, because we're going to take that and, embed it somewhere, right? So now we're looking at, best practices is one, if you want a full sentence. How about this one? Calculate the area of a circle. This one says calculate the area of a circle with a radius of 3 inches, round your answer to the nearest integer. Again, consider the output. And here we're telling them, well, I don't know how it can do prompt one. It might tell you the formula for calculating the area. I think you probably need that first sentence in both if that's what you're looking for. But here we're telling them round the answer to the nearest integer. So that's considering the output and what we want that output to look like. All right. How about this one? Summarize this event versus why did this event happen? So, we do have one of our things that says start the prompt with a question. If this is what we're trying to get to, then that's a much better answer, right? So telling it to summarize something will literally just summarize it. If you're trying to get an answer to a question, make sure you pose that question. How about this one? Prompt one says determine the sentiment of this social media post. So we give them the text of a post and say, is this a positive thing or a negative thing, right? In prompt two, what we're doing is actually giving them some examples. We say, here's a post, great pen. That's a positive result. I hate when my phone battery dies. That's a negative one. And now here's my new post. You tell me, is it positive or negative, right? So this is called few shot prompting, where we give them a few examples to learn from. In the end, you're going to review those responses, consider the quality, the type, the range of responses, make changes to the prompts as needed. That's some basics. Now, let's go a little further into some of these prompt techniques. So when you don't give them any examples of like what you want it to do, we call that zero-shot prompting, where you basically provide a task to an LLM with no examples, no shots. of the task. Um, the larger the LLM, the more effective the result would be, right? So here's an example where we tell them, tell me the sentiment of the following social media post and categorize it as positive, negative, or neutral. And then we give them the post. They look at it and say, I think this is positive, right? If we're using a very large language model, it could probably figure it out pretty well, right? So that's the idea of zero shot prompting. Now, if you do some further fine tuning on a foundation model, um, um, there's a type of fine tuning called instruction tuning. This differs from like traditional fine tuning because it focuses on the instruction itself, not just the task. So you provide the model of examples of instructions and the corresponding responses. So if you've given it a bunch of tweets in the past and said they're positive, these are negative, you can get it better at um, you can get it better at uh, doing that kind of sentiment analysis, right? Now, we saw the zero shot prompting. Somebody said, aren't you giving it positive, negative, neutral? Well, this is more of the output format, like rather than a sentence, just categorize it as one of these three. We're not giving them a bunch of examples and telling them these are examples of positive, these are examples of negative, right? So few shot prompting is where we're giving, actual labeled things that are either positive or negative or neutral. Okay? And here's an example. Okay, so tell me the sentiment of the following headline, categorize it as either positive, negative, or neutral. Here are some examples. And so we give it headlines, and then this is negative, this is positive, and then here's another one. What's the answer? And it says, oh, it looks negative to me. Okay. Um, Now, the problem we run into here is that we do have to worry about the token limits of your LLM, right? Because you've got a certain number of words that so I'm not putting thousands of examples in there, or I might be hitting my token limits. And the more tokens go in, the more tokens come out, that's going to cost more when it comes to actually use the model, right? So price comes into play here. But you got to balance that, so how many shots is the right, you know, and if you can find a few different examples that really typify, or maybe look for edge cases where, when sentiment analysis, one of the tough ones is like sarcasm, you know, like I get a tweet that says, I love it when United Airlines loses my bags. You're like, is that positive or negative? I said I love it, but it's not really positive, is it? Right. So um, you know, the large language models are pretty good if you got a really big one, right? To figure that out. But it helps if you've done some, few shot prompting that shows some examples like that. Right. So that's sort of a nice example that, and that was one of the best practices we saw. Another kind of best practice that we run into now is called the chain of thought prompting. When you have a task that involves several steps, or there's a series of reasoning things that need to be done, you can tell it um, to use chain of thought. You don't have to say it like that. You can just say think step by step, right? And so here's an example. Which vehicle requires a larger down payment based on the following information? Total cost of vehicle A is 40,000 and it requires 30% down payment. Total cost of vehicle B is 50,000. It requires 20% down payment. And I tell it to think step by step. It says, okay, well, here's what would happen with the first one. Here's what would happen the second one. So, based on these totals, A needs a larger down payment than B. Now, you don't always have to do the think step by step. These large language models are getting bigger and smarter all the time. So I bet that if I put, let me grab this thing without the think step by step. Where do we go? And I go and throw this into Claude Sonnet. We need to calculate the actual down payment for each vehicle. So there it's done. It's basically thought step by step automatically for me because it realized that it was kind of a complex thing. Now, sometimes you know, if it doesn't show you its work, you can always add that thing step by step and do it again and try and get it to show me that. Right? Let's catch up with that slide again. Okay, so we saw this one. So here's a few shot prompt with chain of thought. So in a given week, the viewers for a TV channel are as follows: Monday, 6,500; Tuesday, 6,400; Wednesday, 6,300. How many viewers can we expect on Friday? And then answer based on the numbers given. So here I'm actually giving it some further information. And then we say, well, how many can we expect on Saturday? I bet we could do this without the few shot even. I wonder if we even need to think step by step. Like I said, things are getting smarter and smarter. Let me try this. Let me grab that text and I'm going to throw it back in here. 6,500, 6,400, 6,300. How many viewers can we expect on? Let's just jump straight to Saturday. I think there's not enough information. Data provided only covers viewership from Monday to Wednesday. It doesn't give any information. To predict for Saturday, you'd need additional data points. Okay. Without any additional context information, we can't provide a reliable estimate. I wonder if I just say on Friday, what would it come up with? Same thing. Okay, let me add the think step by step. See if that fixes anything. Okay, now it says, okay, we're going to analyze the patterns. Monday, Tuesday, Wednesday, find the pattern. So it's going to look at the pattern. It says it decreases by 100 viewers each day. Then probably it'll do the same on Friday, right? It says, okay. But this is an assumption based on very limited data. It says, I think we can guess Thursday will be 6,200, Friday be 6,100, but we really don't know, right? So the thing step by step certainly helped in here because it told them, there is something, if you look at it step by step, maybe there is more you can get to it. So that's an example where the chain of prompt really did help. The chain of thought. In addition to chain of thought, we also have another one called tree of thought. And this is where, say you have multiple paths that can be taken and you want it to go down each of the paths and keep track of, you know, think step by step in parallel with different options, and then get to, maybe different results based on which of those paths it actually takes. So there's some really interesting stuff that you can do in there. Now, this is sort of the end of this official material. Now, I do have some other material I want to grab here. So I'll tell you what happened. This webinar, the discovery days were built probably about, well, they probably started it about a year ago. And in between, AWS has actually, done a lot of work on this. And we now have a new generative AI essentials class. And they have a really nice, section on prompt engineering in there. I'm going to borrow a couple slides from that class to really go through and round out what we just talked about. So in that class, we now talk about a few different components of the prompt. So there's the task. That's where you say, what you want to do. I want you to analyze the current market trends in e-commerce or something. And then the instruction gives maybe more detailed guidance. Focus on the top 3 emerging technologies in the field or something like that. Then the input is whatever data that we're passing in, relevant statistics, whatever. The output, again, you're going to tell it, um, you know, the format. I want this to be bulleted or, headlines with bullets, whatever. Tone and style, again, professional and concise, friendly and conversational. Who's the audience in for? That kind of thing. And then any constraints that you want, any limitations, restrictions that the model should adhere to, avoid certain topics, you can give it specific guidelines. And then we can go even further and provide even more details in there. What's the role? What persona should the AI be taking on? You know, so a lot of times I end up having to create practice exam type questions for, like I'm doing a class and I'm going to generate some like exam type questions. I say you are writing practice exam questions for this exam, right? And so I tell them this is who you are as an AI, and this is what I want you to do. Right? So we can give more of a role, so that the perspective or expertise the AI should adopt. You're a financial analyst, whatever you are, right? The subject matter, the topic, that kind of thing. The output, again, desired format, type of response. Do you want a report? Do you want a list? Whatever. Um, the tokens, well, that's the actual words we send in. The structure. Oh, structure is more like the organization and flow of the expected response. Um, Exclusions, things you don't want to see. That's kind of an interesting one. The audience, for like who you're talking to. Document, maybe you can tell it some external resources to use. The examples, that's for few shot prompting. The length, we could say in 2 sentences or however many words. The format, very specific. Um, I think we're missing an N there in boundaries. Um, but we can get a lot more specific. So here you're an experienced business process analyst specializing in supply chain optimization. So that we're saying the generative AI model is this, and here's your task that you need to do. Right? And we provide some data. That's the input. The instruction in your response include the following sections. So we can tell them, here's these specific uh, uh, sections I want. And the output, I want bullet points and text formatting, markdown. You can tell it all kinds of information. Now, remember a few things. The same prompt, will it work with the same with different foundation models? No, they're trained on different corpuses of documents. They're trained slightly differently. Some of them have been trained using some human feedback loops that are different. So, different models will give you different things. Different models on different days will give you different things. Mhm. Why do I get the different responses sometimes when I run a prompt? There is some probabilities in there. Do I need to include all the prompt elements and components in each prompt? No, certainly not. Right? But again, we can look at some where we say, write a market analysis doc. That's pretty broad, right? So here's a little bit better prompt. Include at least 3 business use cases, use data from leading business publications. So if I go and run this, actually, let's run, I'm not going to do that right now. But it'll quote Forbes or Gartner or somebody like that. So here's take that good prompt and make it even better. Tell it the context. You're an AI assistant with expertise in business strategy and market analysis. You're analyzing current trends in e-commerce. Provide a structured response with clear headings and bullet points. At least 3 major trends and list associated impacts. And then here's the tone you should use, right? So it's going to get better and better everything I do. And if I give it even more information about the output, I want a well-structured report with the following sections, right? Now I think we're missing some things here. This is just the output format, but we need the specific requirements and the tone and everything else. And so the more you put into that prompt, the better the prompt is, the better the result is, right? And so that's the big thing to remember here. And so it's the advanced prompting. We talked a little bit about few shot and zero shot, um, single shot where you provide one, you know. Um, One thing that we didn't mention, which it's not exactly prompt engineering, but it's another one of those options in addition to fine tuning and prompt engineering, is called retrieval augmented generation, RAG. This is where you point it to some sort of a knowledge base and say, I haven't I haven't tweaked the actual model. I'm not fine tuning it and retraining it, but I'm taking that foundation model and I'm pointing it at my database and I'm saying, here's the data that you should really be checking things against. Right? And so you've got your foundation model, whichever one it is, and then you've got your company data. Maybe it's a database, maybe it's a bunch of text files or whatever, and so you point it at that and you say use that. And so we can actually build like what we call guardrails in Bedrock that say, that data, like if you're going to quote data in your response, it better come from the foundation model. And so that's sort of another kind of a way to tweak things and make them a little more, specific to your domain, to your data. We sometimes talk about tool use prompting, where we tell it to use specific tools, like here, use a calculator to solve this equation. And so you can tell it what to use, or here, analyze this data and create a chart, or maybe even a specific type of chart. So that's action-oriented prompting. We talked about chain of thought, where we tell it to think step by step. Tree of thought is where we explore multiple reasoning paths and it evaluates intermediate steps along the way. Another thing to mention maybe is the negative prompting. So don't include this, avoid mentioning these things, so you can tell it what to avoid as well. And here's some other, things. I'm not going to get too much into those. So I just wanted to include those as a couple of other things just to mention. If you want to go from here and learn a lot more about prompt engineering in AWS Skill Builder, we actually have some, free Gen AI resources, including a little thing on prompt engineering. Let me pull my stuff back up about our company. Do quick little marketing bit here about us. I did want to mention here's all the different AWS certifications that exist. You'll notice that AI and ML is starting to account for a lot more. So we have a couple of brand new certifications. So notice here under foundational, we've for a long time now had the cloud practitioner, where you don't have to be heavy duty technical person to get that. Well, now they've added this new AI practitioner. Oops. Oh, here's the link. Let me throw that link into the chat if you're looking for it. So that's where I got this picture. But AI practitioner, it's not quite as easy as the cloud practitioner, right? It does expect you to know a little bit about just Gen AI in general, a little bit about prompt engineering, and a little bit about the AWS services. So you'll have to do a little study on that. But there's lots of good free resources in Skill Builder for that. Or you could take the one-day Gen AI Essentials on AWS class. That'll really help prepare you for it. The other new certification is, oops, I keep clicking in the middle of the picture, which I don't want to. Here it is, the Machine Learning Engineer Associate. Now, this is a little bit more substantial because it is an associate level certification. So if you've ever gone for the Solution Architect Associate or something like that, you'll know normally we have like a 3-day class that maps to that somewhat, and we do have that. And so this is a lot broader than just Gen AI. It's machine learning in general, and building that pipeline of getting your data cleaned up and ready and all that kind of thing. And then we've had the ML specialty certification for a while now. And so here are the official AWS classes that we provide that are applicable here. The closest one here would be the one-day Gen AI Essentials on AWS. It maps to that practitioner. We've got upcoming dates, June, July, August. So we run this about once a month, probably every 3 weeks or so, it looks like. We have a longer 2-day class, but it's more geared towards developers building applications with Gen AI. Doesn't really map precisely to any certification, but we also have that running probably every 6 weeks, it looks like. Um, the new 3-day class on machine learning engineer just came out yesterday. So our first date, we weren't sure when, if they would make the May 20th release date. So we gave ourselves a buffer. Our first public date is June 11th. So this is a 3-day class. It maps to that new machine learning engineer associate. It's very good class. And then we have the ones that have been around for a while, the 3-day SageMaker Studio class and the 3-day ML Ops engineering class, which sort of takes the ideas of DevOps and building a pipeline and applies that to machine learning. Both of those are sort of, you know, at least partially how you would prepare for the specialty certification. Mhm. So those are all hyperlinks there. Oh, I'm going to share these slides with you, I guess. Yeah. And then you'll have all those links. Actually, yeah. And then this is just, our top courses kind of thing. So I wanted to give you all that. The other thing I want to do is I'm going to throw my email address into the chat. If you've got questions after the course, this is the best place to send them, is send them to me. If you're interested in, a particular course or something, I'll probably forward that on to one of our salespeople. But if you just have questions, you can send them there. Now, if you have questions now, throw them in the chat. Sumi asks, is there a badge for this course? Well, this isn't really a course. This is just webinar, so we don't have any badges for this. But I'm going to stick around for a few minutes. If you've got any questions, you can get them in there. What else did I want to do? Oh, yeah, I wanted to see if I can put into the chat. Let me find my chat again. Here's the chat. Let's see if I can throw. I think it's going to work. There, you may be able to download those PowerPoint slides from the chat. We can take steps of the figure graph that you showed us. I'm not sure exactly what that means. Steps of the figure graph that you showed us. Oh, yeah. Well, let me show you this. Let me just pop open Skill Builder. And actually, if you just go to Skill Builder, even if you're not signed in, if you go to the Prepare for Exams and you say, let's look at the AI practitioner, it says, well, here's a bunch of resources. If we skip past the exam prep stuff and just get to this, refresh your knowledge. There's a whole bunch of these that are digital courses that are free. Now, eventually you'll get to some things where they've got labs or something where you have to pay. So for those, you have to have a paid subscription for Skill Builder. For all the ones that say free, you can just use them. You just sign up for Skill Builder free account. You need to know a little bit of the fundamentals of machine learning and our AI use cases, responsible AI, a little bit of Gen AI developing solutions, essentials of prompt engineering. This is very similar to what we just looked at here. It's about an hour. Optimizing foundation models. They talk a little bit about RAG and a little bit about fine tuning, security and compliance. So they've got a whole bunch of these. Some of them are an hour long, some of them are shorter than that. And if you go through all of those, you're pretty much ready. You could go do that exam. Will you share the PowerPoint you just used for the prompt examples? No, I can't share that one, unfortunately. Yeah. But this recording should be recorded on our website. So you should be able to get those. Oh, I see. Yeah, as far as the certifications go, you don't need to get them in any particular order. Um, Certainly, as far as like easiest to hardest, the AI practitioner is definitely the easiest. You don't have to be deeply technical. And like you saw, there's about 7 1-hour videos you watch. You do all that, a little bit of study, you should be good to go on that. Um, the machine learning engineer is an associate level. So I would say, you know, the easiest way to prep for that is to take a 3-day class and then go and do some study. But if you wanted to do it all on your own, if you had the paid subscription to Skill Builder, you can use some of those resources. The specialty exams, these are for people who've been using AWS a long time and been doing machine learning a long time. So those are quite a bit harder, right? That's what I would say as far as the steps to go. But certainly, if you're looking for an order to take these classes, top to bottom here is probably the right order if you're going to take them all. You can certainly get away without this second one, unless you're a Python developer of some sort. All right. Well, I think that brings us to the end. Yeah. All right. Well, thank you for attending this webinar, and hopefully we see you in a class down the road. Good luck with Gen AI, and like I said, prompt engineering. It's more of it's somewhere between an art and a science, but it is not heavy technical, right? You just tell the AI who it is, tell it what it should be doing, tell it who it's talking to, and what you want it to say, how you want it to say it. All right. Have a good day.